Hi and welcome back to ScottiesTech.Info. I'm Scotty with my co-host Cletus, and today I want to talk about big data. Specifically big data in terms of, it actually means several things, but it means the amount of data, storing massive quantities of data, processing massive quantities of data. Big data also refers to sort of like the mining of that data, spying and that sort of thing. But in this case, when I talk about big data, what I mean is like how much storage space is required, how much processing power is required to make things on the internet go. So I'm going to talk a little bit about some interesting and fun facts and statistics about YouTube and Google and the internet at large. And the reason for this is because I came across a statistic the other day about the number of videos that are uploaded to YouTube per day. And frankly, even though I'm kind of a techie and I'm more or less aware of this stuff, my mind was pretty much blown. So let's start with YouTube. YouTube apparently has approximately 1.8 billion logged in users per month. That's a lot. That's logged in only. That's not everyone. So obviously the numbers are probably higher. Each of those people is probably watching, multiple videos. In terms of the quantities of videos, there are several estimates for this, but the most recent one that I could find is that 65 years of videos are uploaded per day to YouTube. Okay, so what that means is that YouTube is so big and there's so many people uploading videos to YouTube that between the time when you woke up yesterday morning and the time that you woke up today, if you woke up this morning and you said, I want to watch all the videos that have been uploaded in the past 24 hours, it would take you 65 years to watch them all. That's the statistic that blew my mind. In addition, over 1 billion hours are watched per day. So 65 years of videos are uploaded per day, and every day 1 billion hours are watched. That's 1 billion hours is 114,000 years. Actually more than that. So 65 years of videos are added every day to YouTube, and also every day 114,000 years of videos are actually watched by people. And of course, there's an estimated like 3.5 billion net users. So if you say like approximately a third of those watches an hour of YouTube a day, that accounts for, your 1 billion. So that, that makes sense. Okay, in terms of storage space, let's see. In terms of storage, this is actually a very difficult metric to. You have to understand that companies like YouTube and Google, Facebook, Instagram, all these different companies, some of which, Google owns YouTube, Instagram is part of Facebook, but the point is that a lot of these companies, in fact most of them, they're not very forthcoming about the amount of data processing power they have, the amount of storage space they have, the amount of electricity that they're using. So it's very difficult to get accurate facts and figures, but we can get an idea because occasionally every now and then they report certain things. And so in terms of the amount of storage space that YouTube has, as far as I can tell, they have millions of terabytes or multiple exabytes of storage space. And this actually gets complicated because, okay, so they have millions of terabytes. You may have a 1 terabyte hard drive in your computer, right? They have millions of terabytes at least. And storage space on YouTube is actually kind of an interesting topic because when you're talking about big data, if you copy a video file to your computer, it's very simple. You have say a 300 megabyte video file, like an MP4, for example, and you copy it off a USB stick and it sits on your hard drive in one place. When we're talking about big data like YouTube and Google and Facebook, they have so much data that they can't store it in the same way. In fact, I forget what the name of it is, Map something. Google invented their own data storage techniques, and they've done all this crazy stuff and separates the data in chunks and puts it in weird places and does all kinds of crazy things. So estimating the total storage space is one thing. Okay, so it's probably on the order of millions of terabytes, probably very more by now. But uploading a video to YouTube, it's not the simple case of you just put the file up and boom, it's done. Because what they actually do is, if you're a less popular channel, obviously YouTube has data centers like all over the planet, right? So you upload a video, and if you're a less popular channel, that video file may get stored in one location. And so then if a bunch of people from other locations try to access it, it's a bit slower. If you are an extremely popular YouTuber, then they will take the data and copy it to multiple locations. So you might upload a 300 megabyte video, but multiple copies of that 300 megabyte video are being distributed to their different data centers so that people can actually view it faster because it's popular content. So they have a lot of storage space. Especially if 65 years of videos are being uploaded every day, and many of those are being copied into multiple locations. Then there are other issues like transcoding and all kinds of crazy stuff, but I'm not exactly sure how they do that. So the point is, at least millions of terabytes, probably a lot more than that, and it's continually growing. So that's a lot of storage space. And finally, one last fun little statistic. The top earner on YouTube is Ryan ToysReview, who is a 7-year-old who reviews toys with his parents, and apparently last year his channel earned him, at the age of 7, $22 million, $21 million of which came from ads on his videos. Clearly, I am making the wrong type of video. So anyway, we all know that YouTube is a part of Google. And of course, when you talk about big data and giant internet companies, Google is pretty much number one. So now Google has 16 custom data centers all around the world. In 2017, they had 15. Now here we are in 2019. They've added yet another one. In these 16 totally custom data centers, apparently they have underfloor laser intrusion detection and iris scanners. So Google data centers are like something out of a James Bond movie. It's like more secure than like the CIA or the NSA or something. It's pretty funny. Anyway, they spend billions of dollars per year typically on new data centers, or to keep existing ones upgraded, because this is another aspect of the kind of big data stuff that we're talking about. Is, when you have a computer, it's like, it's 5 years old, maybe I should upgrade it, so on and so forth. If you are, say, Google, and you're running a data center, you need to be continually upgrading everything, because you don't want to be using processors that are 5 years old, because modern processors, they can maybe access more RAM, they have faster interfaces, they're more energy efficient, they're more, like, in terms of like power per watt, processing power per watt, it's continually going up. So these guys are constantly upgrading things because they have to, because they want to minimize their electrical usage, maximize the performance they get in a given amount of space. In the past, Google actually used data centers that were effectively warehouses, and they took 40-foot trailers, like a tractor trailer, like big truck, 40-foot trailers, each of which was filled with, I think, 1,160 servers. And it had cooling built in and electric distribution built in, and they would take these trailers and just kind of pile them up, stack them up, and then connect them to the grid, connect them to the internet, connect them to each other, and they called them modular data centers, and that's what they used to do. Now apparently they've gotten away from that, at least as far as I can tell, and now they have highly customized data centers where they don't even use the same type of server racks that like a normal hosting company, where you might rent a monthly dedicated server for hosting your website, for example. This is like way beyond that. Everything they do is apparently custom now. They have custom cooling systems that are supposedly better than what anyone else has, and there's a lot of ingenuity that goes into it, and it's actually pretty nifty. So anyway, they spend a lot of money each year on data centers, and they also use a lot of electricity, because all that storage space, all that processing power, obviously they're going to need a lot of juice to run it all. So it turns out that in 2017, Google bought 3 gigawatts of renewable energy in the form of solar and wind farms. And They claim that 3 gigawatts is enough to power all of their offices and data centers all over the world. So this was 2 years ago. They said, basically they came out and said, we're using 3 gigawatts of power. And now to give you some perspective there, 1 gigawatt is more or less the maximum power output of a modern large nuclear reactor. So what that means is that Google's electrical energy consumption is equivalent to 3 modern large nuclear reactors running at full blast, 24 hours a day, 7 days a week, 365 days a year. That's a lot of power. So in any case, in 2017, they came out and they said, we bought all these like solar panels and wind farms and this kind of thing to generate 3 gigawatts of power, and they're not using that power directly because obviously if you have like a data center in London, well, you can't put solar panels everywhere because you're not going to have a lot of sunlight. So solar and wind power needs to be ideally located geographically speaking. So what they do is apparently they power all their data centers and offices and just pay the electric bill. And then they also have invested in these solar and wind farms, which generates 3 gigawatts of electricity, which they then sell back to the grid. So they pay their electric bill, but then they sell back the same amount of power to other users and get that money back. And so therefore they claim they are now like carbon neutral and, all that kind of stuff. So that was also kind of interesting. Speaking of electrical usage, so the internet at large, like when we talk about the internet, we're talking about not just like Google's data centers or Facebook's data centers. We're talking about all the connections between the data centers, the fiber optic cables that run all over the planet, including under the oceans and everything, connecting everybody together. We're talking about the smaller telephone companies and internet service providers, cell phone towers that provide data connections to smartphones, the entire infrastructure that forms the internet, including, say, you sitting on your tablet or your computer watching this video, and you're using some kind of connection to the internet, and that's connected to some company, and that's connected to the bigger internet. All of that stuff all together, the whole internet. The entire internet uses 70 billion kilowatt hours per year. Now, to put that in perspective, that is the equivalent to 8 modern large nuclear reactors, 8 gigawatts, 24 hours a day, 7 days a week, 365 days a year. Now that's kind of interesting because if that estimate is correct, the entire internet is using 8 gigawatts, 8 nuclear reactors worth of power all the time, and 3 of that is actually Google. So you can understand why they wanted to do the renewable energy thing, because their electricity bill is obviously pretty big. In fact, just the electricity to power the internet at 8 nuclear reactors worth costs $7 billion a year. So if Google is using 3 nuclear reactors worth, they are paying approximately $2.6 billion a year in electricity costs, which obviously is going to eat into their bottom line. Now apparently they've got the solar and wind to recoup that cost, which is probably a good thing. It also reduces the strain on the grid because, it's a good idea. Also, in terms of electricity, cooling is 40% of the total bill. So when you have a data center, you have all these servers, and as we know, things that use electricity, like computers, generate heat. And if your computer overheats, you're in big trouble. So when you have giant data centers filled with thousands and thousands and thousands of servers, thousands of computers, you're generating so much heat that you need to remove that heat. So there's like massive chiller systems to suck all the heat away and dump it into the atmosphere or whatever. That process, it's like 60% of the electricity that they're using goes towards actually doing stuff, and the other 40% is just to keep everything cool, and that's just to make the internet go. So moving along here, approximately, we'll get into some fun little statistics about actual internet connections, and 55% of the population of Earth has internet access. Now, this one is kind of interesting. Which country has the fastest average download speed? Now, this is average download speed, so you might think you know the answer to that question, but the country with the fastest average download speed on planet Earth is actually Singapore at 60 megabits per second. Number 2 is Sweden at 46 megabits per second. Denmark is number 3 at 43 megabits per second. Norway is number 4 at 40 megabits per second. Romania is number 5 at 38 megabits per second. And the USA doesn't enter until number 20 at 25 megabits per second. So that was a little bit surprising. Now, of course, that depends because, maybe in certain countries, most of the population lives in urban centers. Fiber, is more prevalent there. In other countries, you have more rural areas, and obviously that infrastructure hasn't been built up yet. So this is just average total download speed, the average of all the broadband users in that country. But it's still rather surprising that Singapore is number 1. Now, in terms of total internet bandwidth usage, when we talk about the entire bandwidth of the whole internet, which is somewhat difficult to measure or quantify, we can still get a general idea of the amount of data going over the networks in any given time, and then estimate how much of that data flowing over the entire internet, how much of that data is used for this versus that. And it turns out that Netflix accounts for 15% of total internet traffic. YouTube is 11%, and BitTorrent accounts for 22% of the upstream, i.e. your computer is uploading files, sending files out via BitTorrent. So BitTorrent accounts for 22% of upstream bandwidth. Netflix and YouTube account for 26% of downstream bandwidth. You are downloading stuff, viewing videos, whatever. In terms of the web, all the websites, 55% of websites are in English and only 4% are in Chinese. Yet, of all internet surfers, 27% have English as their primary language and 25% have Chinese as their primary language. So, over half of internet users are primarily English and Chinese speaking, and of that half, it's almost split down the middle, English and Chinese, and yet 55%, over half of websites are in English and only 4% are in Chinese. I thought that was interesting. Okay, so the total speed of the internet. Obviously, we have an idea about bandwidth, and we can say Netflix is using up 15% of bandwidth because everyone's watching Netflix videos. But what is the actual total speed of the internet? Well, that's kind of difficult to actually measure because it's really kind of like the speed between point A and point B. For example, if I want to go shopping on AliExpress from where I live in France, what actually happens is the connection is made from where I live up to Paris, then I think it goes up to London, then over to New York, then there's several more hops as it goes through the US and finally ends up in Texas of all places. AliExpress thought it was a Chinese company, but for some reason it's being served from Texas. Whatever, man. So, so what is the speed of that? Well, that's kind of hard to say. If you have, say, a hosting company, like I mentioned earlier, you rent a server to run your website, you're paying a monthly fee, there is a physical server, a computer at a hosting company. That hosting company has, hundreds or maybe thousands of other servers, and you are paying for the exclusive use of one of those. A company like that, a hosting company like that, they might say, oh, well, we have 4 terabits per second of bandwidth. So actually, if you live in Singapore, the average download speed of your connection is 60 megabits per second. And if you're, say, a hosting company, the speed of your company's connection to the internet at large is 4 million megabits per second. So we can get little ideas like that, but one of the things that we can actually quantify is the amount of total actual traffic going over, the amount of total data being sent in, say, like a given month or a given year on the internet as a whole. So estimates for that are that in 2017, the total net traffic on the whole internet was 122 exabytes per month, which is actually 122 billion gigabytes per month. So if you have, say, a smartphone and it has 32 gigabytes of storage, it takes you a while to fill that up. The actual, for the whole internet, the estimated total amount of data transferred in 2017 was 122 billion gigabytes, which works out to 1.4 trillion gigabytes per year. And of course, this is always going up. Just as big data and Google, the likes of Google and YouTube and Facebook, they're constantly trying to improve their systems. They're constantly trying to make them more energy efficient, reduce electricity costs, increase processing power, increase storage power, storage space. In addition, everyone's adding all these crazy, machine learning and artificial intelligence. I mean, it takes a lot of processing power when you're sitting in your living room and you say, Alexa, what is the weather going to be like tomorrow? That thing has to take this data and shoot it off to their servers, and their servers have to crunch numbers and process speech and then figure out what you want and then look the data up and do all this stuff and shoot it back. And all of that requires an absolutely phenomenal amount of electricity and processing power and storage space. And it's only getting worse / better, depending on how you want to look at it. So there you have it, some interesting and fun facts and statistics about big data and the internet as a whole. It's all pretty nuts. For more techie tips, see ScottiesTech.Info. Thanks for watching. See you next time.